In this video, I will show you the real power of EF Core mappings, but not just how it maps domain models into data models. That is important for inserting and updating. We will go further from there and look how it maps queries. That is where the real power and the real magic hides. You will be able to query the domain model in C# in memory, and EF Core will translate all those terms you use into actual SQL terms for the database. And sometimes it will be so clever and so, how do I call it, strange, that you will say, there must be some dark magic at work here. This is not possible to do for a tool, but no. EF Core 10 will do everything it can to let you work comfortably with the domain model in memory, and it will perfectly translate your intentions into the SQL code. That's what I will show you in this video. So let's begin with code. We're going to model a money transfer and persist it to the database using EF Core 10. This transfer class is where we will start building that model. The transfer will be composed of several nested objects. We will build this model from the bottom up, so the model complexity accumulates in a natural way. The currency record is a good starting point. It holds a currency code and the number of decimal places that currency uses. We are free to add a validation rule directly inside the currency record. That will not affect our ability to persist the object using EF Core. This keeps the invalid state out of the model entirely. We can also add static instances for well-known currencies and other instance level or static methods we might need. None of this interferes with how EF Core maps the type. The point is that the record remains a fully capable domain object, not just a data container. Yet with both properties mapped to individual database fields and with constructor parameter names matching column names in the database, this entire type is directly usable in EF Core with no additional code in it. The situation will change a bit when we get up the hierarchy of objects and try to model money. It holds an amount and a currency. It is straightforward for the moment, but EF Core will have some issues with it. Its constructor parameters do not match table columns, but rather match our object model. You can still enrich this record with instance members and validation or sanitization logic. This kind of data cleanup belongs in the domain model, and it fits naturally here. But none of this helps EF Core restore this object from the database. What will really make a difference for EF Core is adding a private parameterless constructor. EF Core needs to instantiate an object before it can populate its properties. And so it creates an empty shell first, then fills in the values for the property setters. The private constructor fills the dummy default values just to silence the compiler. But you have to be careful here, especially in record types that have a primary constructor. All properties must be settable to defaults, which are null in case of reference types. Make sure that the object itself accepts all defaults, or otherwise EF Core won't be able to recreate it from the database. In a domain-centric design, we assume the domain model validates the object, and hence all the data in the database have already passed validation. Hence whatever EF Core populates back using reflection will be valid. Never lose that detail from sight when working with EF Core. Bottom line is that this type is now fully persistible using EF Core 10 along with the complex currency object it contains. That brings us to the most complicated type in our domain model, the transfer class. We start by giving transfer its most essential property, the amount being transferred, which is of type money. That is the complex type, so start thinking of how EF Core will cope with it. But there is more. In the best tradition of domain-driven design, the identifier of a transfer is not a plain integer or GUID. It is a strongly typed value object which wraps the actual key value. You will see this type in a minute. It will also require a mapping in EF Core. And here is another property, the timestamp of when the transfer was executed. Notice that this is not a plain date time. Every meaningful piece of data in this model gets its own type. That is the core principle of domain-centric designs. Let's pay a visit to these types then. The timestamp is a record wrapping a single date time value. The only thing it enforces is that the value must be in UTC. That is the entire purpose of this type, to make it impossible to accidentally store a local time. We will use this type later when constructing transfer instances and querying them at different times. A convenient method will add a time span to a timestamp, returning a new, safe UTC timestamp. That is why we design such small types in the domain. They help us keep the objects valid at all times. Comparison operators will help us compare timestamps using the familiar syntax. This will also be important later when we start writing queries to filter the transfers by time range. The important message here is that persisting a model with EF Core should not stop you from developing rich syntax around it. Use all your knowledge of programming and domain modeling and leave EF Core do its part. Those are two separate activities. We witnessed that in the transfer ID type 2. It wraps a plain GUID but adds two important guarantees. First, it prevents accidental cross-assignment between different ID types in the domain. Second, it ensures that the ID is never an empty GUID. A convenient factory method generates a fresh unique ID, helping us use this type. Back to the transfer class, the root of our domain model. Our next task is to configure this type along with all the supporting smaller types for persistence with EF Core 10. We start by adding a parameterized constructor, giving callers a clean way to initialize a transfer in one step. But that impedes reconstruction of objects from EF Core once again, because parameters are complex types rather than database fields. The solution is again a private parameterless constructor that chains to the primary one, passing dummy defaults for each parameter. EF Core will use this entry point in combination with property setters to reconstruct objects from the database, while keeping it private ensures it stays invisible to the rest of the application. We can now move on to configuring EF Core. All domain types I planned to persist in the database are complete. The database context is already in place. It exposes a set of transfers and the model creation hook is ready for configuration. This is where we will wire up the complex properties and value conversions in the steps that follow. And you will see, despite the immense power that EF Core will exhibit when we start using it, the mappings I will put here will be simple and straightforward. I will show you all that by the end, but before that let me steal a moment of your time to remind you that this video and all other videos on this channel are free, but only thanks to the patrons, the people who are sponsoring this channel and making it possible to maintain it as free content. So if you like what you have learned in this video and other videos on this channel, then please consider joining the growing community of patrons on my Patreon page. By becoming a sponsor, you will get access to the source code of this video and all other videos, and also to some discounts I occasionally post on Patreon. Thank you very much. Now let's get back to code because we need to complete the configuration. We start by registering the transfer entity with the domain builder. This is the only entity in our model, so all configuration we need will go right here inside this block. We start with the easy part, the shadow property for the primary key. It maps the column named ID, carefully avoiding the name collision with the ID property in the domain model, which represents a public GUID which we may share with other systems. But mapping of the public ID property will complicate the matters. This is the GUID wrapped in a record type. We want that GUID unpacked from the record and stored as a regular column in the same table. EF-Core's value converter is exactly the right tool here. It handles the one-to-one mapping between a wrapper type and a single database column. Define types involved in the conversion. Implement a constructor that passes two lambdas to the base constructor, one unwrapping the record to get the raw GUID out, and the other one converting the raw value back. You can convert almost anything you like this way. Look at the timestamp record conversion. The time kind is lost when saving to the database. To make sure the date-time value is explicitly marked as UTC, we set its kind explicitly before passing it to the timestamp constructor. Back in the database context, this is where we wire everything together. Attach the converter, specify the column name and type, then we add an index. It goes almost the same with the timestamp. We attach the converter and specify the column type. It is all so straightforward. But things will change radically when we get to the amount property. There is no one-on-one mapping to a database column. EF-Core treats this as a complex property, and we configure it with a dedicated call. Inside, we will describe how each part of amount maps to the database. We map the amount scalar property to a column with a specified decimal precision. That is important for keeping financial amounts. But what about the currency? It is another two values inside one small type. Then comes the surprise. Currency is itself a complex property, so we nest another complex property call inside the amount configuration. Inside the currency complex property, we map its two scalar fields as usual. Both columns sit flat in the same table right alongside amount and everything else. That is the most astonishing aspect of mapping the complex types in EF-Core. That was all we had to do to configure 5 distinct classes in C# for storage within a single database table using EF-Core's complex types and value conversions. We can finally see the power of all that configuration by actually using it. Given the DB context, this method will insert the transfer records into the database. We can make things more interesting by generating various transfers in different currencies. Then simply wrap each amount into a transfer with a fresh GUID and a timestamp. Add it to the DB set and we are ready to commit all objects into the database. Calling save changes is all that remains to persist everything in one shot. Dealing with persistence is only 2 lines of code here. The rest is making sure to create valid objects. That is the only remaining worry we have when we use EF-Core. Let's move on to demonstrating querying, and with that we will complete this demo. You can query by the entire complex property. EF-Core knows how to translate that into SQL, so this reads just like plain object comparison in C#. You can also query by any of the nested properties, such as checking whether the currency code starts with a given prefix. EF-Core will reach all the way down into a nested object to produce the right SQL. Another example is applying an arithmetic comparison operator directly to a property of a nested object. EF-Core will handle the translation without any extra effort on our part. As the last example, get ready for real dark magic. We want to filter transfers by the timestamp. However, the comparison operator is our custom operator on the timestamp record. That does not translate to SQL. Anyway, EF-Core will figure out it is the greater or equal operator and translate that whole thing into an equivalent SQL comparison on numeric fields in the database. No custom logic, no helper methods, just a plain comparison against a nested complex object. Go figure. Needless to say, all operations have completed with no trouble. After inserting 4 US dollar transfers and 2 Japanese yen transfers, the rest was querying. And so, querying by the dollar currency was translated into the equality comparison on both database fields. The result is truly only the transfers made in dollars. The query by the currency's initial letter was translated into the like SQL operator just as expected. The subsequent comparison of money amounts was equally good, but the last example is again pure magic. We had custom operator overloads in C# to compare the timestamps plus the value conversion into a datetime database field. EF Core has correctly translated that expression straight into the time comparison in the database. How beautiful! And this is the code that made all that magic possible. Mere dozen of lines of code setting up value conversions and complex properties. The rest is just magic orchestrated by EF Core.